This video is going to cover Unit 28, Section 2, Cylinders. A cylinder is a solid, reclap, This video is going to cover Unit 28, Section 2, Cylinders. A cylinder is a solid that has identical bases that are circles. Okay, so here we have a cylinder. There's one base there, and there's the other base there. They're both circles, and they are parallel to each other. Okay, the area between the two bases is the lateral surface. The circles have a line drawn through each center. That's pretty close. In a right cylinder, that is going to be perpendicular to the base. And we will only deal with right cylinders here. So that axis right there is perpendicular to the bases. Okay? Now, the volume formula for a cylinder is equal to base volume times the height. Okay? So for or base area times height. For a circle, the base area is going to be pi r squared. So the volume of a cylinder is pi times r squared times height. Now let's take a look at, what page is that on? On page 708 near the top, you have a figure that looks like this right here. Now this is I think it's bronze. So this is a bronze bushing, okay? So you've got a cylinder here with a hole all the way down the middle of that cylinder. And the objective is to find the volume of the bushing. And then once we find that, I think they want to find the weight of just 1 cubic inch of that substance, which is bronze. So first we need to find the volume of this figure. So first I need to find the volume of the outer cylinder, and then find the volume of the inner cylinder that's been cut away. So if you have the volume of the outer, you subtract the volume of the inner, you have the volume of the bushing. Okay, so let's find this outer one here. So the diameter is 1.9. I believe these are all inches, 1.9 inch. So we take that and we have to divide that by 2 in order to get the radius. So the radius is 0.95. The height is 2.75. So we can use this now. We can say the volume is equal to 3.14 times 0.95 squared times 2.75. So we go 3.14 times 0.95 squared times 2.75 And this volume is equal to 7.79. Okay, so that's the outer volume. Now let's find that inner volume. How do we find that? Let's go back up here to the figure. If the diameter is 1.9 and the thickness here, from here to here is 0.35, once I found the radius is 0.95, which would be from here to right there, if I subtract this off, then I'll have that radius. So radius is equal to, the height is going to be the same, 0.95 minus 0.35, should have been able to do that in my head, 0.6. So let's find the volume of that. We have, let's go down here. Volume of the inner is equal to 3.14 times 0.6 squared times 2.75 3.14 times 0.6 squared times 2.75 equals 3.11. So we're going to call that 3.11. So now I take this and I subtract it from that. So 7.79 minus 3.11, and the volume of that bronze bushing is, volume of the bushing is equal to 4.68 inches cubed. Okay, so they're telling us in part B that the bushing weighs 1.5 pounds. And this is the cubic inches. So what they want is what the cubic inches of one cubic inch, or what the weight of 1 cubic inch is. That's what they want. So I can do this a couple of different ways. I'm going to want to end up with inches cubed in the numerator. So I'm going to start this way. I'm going to say that this figure is 1.5 pounds per 4.68 inches cubed. And what they want is inches cubed in the top. Here's what I want. So 1 inch cubed. I'll put a 1 in the bottom. So inches cubed cancels, inches cubed cancels. And once I figure this out, I'll find out how much that weighs. So 1.5 times 1 over 4.68 times 1. So 1.5 divided by 4.68 is 0.32. 0.32 pounds per 1 inch cubed. Now this could have been done a little differently. I chose to use the unit analysis method You could have just simply gone with a unit rate on this and, of course, divided 1.5 by 4.68. There's always more than one way to do a math problem, but I chose to continue going with the unit analysis because that's what I did with the prisms. Now notice something, that the volume of a cylinder, the base volume formula, is the same as the volume formula for a prism. The difference is, how do we find the area of the base? So the volume is equal to the base area times the height. For a cylinder, the base is a circle, so the area for a circle is pi r squared. For the prism that we talked about last section, the area of the base was the length times the width, which was rectangular. Or whatever that was, I think, what did we use? We used a triangle on that one. So we found the area of the triangle, which was base times height divided by 2. But it could have been a rectangular. It can be hexagonal, octagonal. You just got to find the area of that base. Generally, for me, I will use triangles and rectangles because they're easy enough to find the base of. To find the base of a hexagon is a little bit more complicated.